So this is Algebra 2, Section 1.3. We are just going to talk about a little bit of 1.3, where we look at following order of operations when we evaluate expressions. And then we're going to jump into Section 1.4. There's 3 learning objectives for that section. The first is solving algebraic equations. The second is solving word problems by first writing an algebraic equation. And then the third part is solving literal equations for a given variable. That third one we will save for tomorrow. All right, so order of operations. When evaluating expressions, you must follow those. Our first one, parentheses or any type of grouping symbol. That could be the rounded parentheses, the more squared off brackets. It could be a fraction bar. That also represents a type of grouping symbol where you have a numerator separated from the denominator. And then our second step is to deal with any exponents or powers. Then we tackle any multiplying or dividing in order from left to right, which is very important. And then our last step is to deal with all the adding and subtracting. Again, it has to be in order from left to right. So when we look at evaluating this first one, my suggestion to you is whenever you are substituting a value in for a variable, make sure you put it in parentheses. When you take the variable out, you put parentheses around the number that you're dumping in. And that's important, especially when we're raising those numbers to powers and they're negative. So a negative 2 raised to a second power turns into a positive 4. Now the only reason that we have parentheses in there is to represent multiplication. So we could have written it as 10 minus 3 times 4. Then we deal with the multiplication before we deal with subtraction. So we'd have 10 minus 12, which ends up being a negative 2. Now I'm going to jump down here for a second. We'll come back to part B. But if we look at that same question we had in part A, where it was 10 minus 3x squared, and we were substituting in a negative 2, if we hadn't put the parentheses around it, it would look like this. And because there are no parentheses, the only thing being squared is actually the 2, not that negative sign. So this becomes 10 minus 3 times a negative 4. And then when we multiply the negative 3 and the negative 4, we get a positive 12, which gives us a different answer than we had the first time around. So that's why we follow order of operations, and we make sure that we include parentheses around those when we're dumping in a negative value. So this is incorrect. Go ahead and cross that out. This is the correct one. All right, part B. We have 2 different variables. Again, I'm going to rewrite the question where I take out the variable and I just put parentheses in its place. So I've taken out the x and the y, and I'm dumping in these red parentheses in place of those. Then I have another x. Then I have a plus sign. I have a y, and it's getting squared. Okay? So now when I go to dump values in, we know that x is negative 5, and there were 2 of those. And we know that y is a negative 3. There were 2 of those. Now I can go through and try to simplify all this. Make sure I follow order of operations, which says start with those parentheses. So I'm going to start with these. I'm going to look inside. I have a negative 5. I'm subtracting a negative 3. That really means I'm adding a 3. Subtracting a negative is the same as adding. So the parentheses turn into a negative 2. Then I notice that I'm subtracting a negative again, so I'm going to add the 5. And I also have a power here that I have to deal with. So before I can add that negative 3 to anything, I have to square it, which turns it into a 9. Then I'm going to go through and finish all my multiplication. 2 times negative 2 would be negative 4. And then I can go through and do all of my adding. 4 plus negative 4 is 0, plus 5 is 5, plus 9 gives me 14. All right, let's jump to section 1.4. We first start out by defining an equation as a statement that 2 expressions are equal. And when we solve an equation, we're really trying to find all the values for the variable that makes the equation true. To do that, we are going to use inverse operations to undo or solve the equation. In other words, if there's addition, something's being added, we're going to undo it by subtracting it. All right, so first question here. We are solving for y. I'm going to go ahead and distribute this -2. So I have -2y plus 2, -2 times -1, equals -16 plus y. Then because there's variables on both sides, I want to move them to the same side. So I'm going to add these two y's to the other side. My next step would be to add the 16 back to the left side. I now have 18 equals 3y. And my last step would be to divide out that 3. So I end up with y equaling 6. Okay? For our second equation, again, we need to do some distributing. I'm going to distribute that -4. So I have 10, -4 times x is -4x. -4 times -2 is +8. I can combine like terms and get -4x plus 18 equals -22. Then when I subtract the 18, I end up with -40. And last step, I can divide, which gives me x being 10. All right. We're going to go ahead and do D next. I want to save part C for a second. I'm going to distribute again a -2. When I do that, I have a -2x minus 6. Combining like terms, I have 4x minus 6. And then I want to get variables to the same side. So I'm going to subtract these two x's to that side. And then I'm going to add 6 back here. My last step is to divide by 2, which leaves me with 11/2. I could also write that as 5 1/2. I could also write it as 5.5. You want to just be careful if you have fractions that don't end up as nice ending decimals to leave it in fraction form. All right, back to part C. There are several ways we can attack this question. Some people would look at it and say, I'm going to distribute the 2/3 right away, like we've been doing on the other ones. However, that creates a lot of fractions and makes it a little messier. Some people would say, instead, let's multiply both sides by 3. That will get rid of the 3 we have in the denominator of that 2/3. We can do that because we're multiplying both sides by 3. However, the easiest option in this case is to deal with the whole 2/3. And I can get rid of this 2/3. It's being multiplied to my parenthesis group. So to undo that, I'm going to divide both sides by 2/3. But that's the same as multiplying by the reciprocal. So I'm going to multiply both sides by 3/2. It cleans up the left side nicely. I just have a 5x plus 7. And on the right side, I can think of 18 divided by 1 times 3/2. I can do some reducing, make that 1 and 9, and I end up with 27. And now it's an equation like we've been solving. I can bring the 7 to the other side and then divide. All right, let's look at solving equations when we start out with a word problem. Notice that it does tell us to write an equation first before we try to solve it. It says the length of a rectangle is 2 more than 3 times the width. So right away, I'm going to picture a rectangle. We are being told the length is somehow related to the width. Then we're told that the perimeter is 60, and we're asked to find the dimensions of the rectangle. So a few things that we need to remember. Perimeter means we're adding all the sides. So if I refer to this as width and length, I need 2 widths and I need 2 lengths to get all the way around the rectangle. Now, we don't want 2 different variables. That makes it too complicated. So instead, I'm going to leave this as W, but instead I'm going to change this. Instead of calling it length, I'm going to write it using this alternate version. We are told the length of a rectangle is 2 more than 3 times the width. So I need to take 3 times the width, which in this case would be 3 times W, since I let that be my width. And then it says it's 2 more than that, so I have to add 2 to that. Now I have expressions for both sides of the rectangle just using the variable W. So I'm going to do some substitution here into my perimeter formula. We are told the perimeter is 60. We have defined the width of our rectangle to just be a W, so I need 2 of those because both of these pieces would be W in length. And then for the length of the rectangle, I need 2 of those. And for the length, we said we had 3W plus 2. I need 2 of those. All right, now it's an equation like the ones we've been solving. So we're going to go ahead and distribute. We end up with 6W plus 4 for the end of that side. Then we're going to combine like terms. 2W plus 6W is 8W. I'm going to subtract the 4 to get 56. And then I'm going to divide out the 8, which gets me 7. Now, we're not quite done with this question because we've found the width to be 7. But we're also asked to figure out the length. And our length, we said, was 3 times the width, so 3 times 7 plus 2 more. So we have 21 plus 2, or 23. So the dimensions of my rectangle would have to be 7 by 23. All right, our last example for today says the map shows the distance between 2 towns in miles. You and your friend drive together from Newtown to Essex. You drive first for a total of 40 miles, and then your friend drives for an hour and a half to reach Essex. What is your friend's average rate? So, keep in mind that your distance, the distance you drive, plus your friend's distance has to equal the total distance. Okay? Now, we're told that we drive 40 miles. So we know that this is just going to be 40. We can also figure out the total distance. They said we went from Newtown to Essex. So if we add up these total miles here, 46 plus 44 plus 37, we get 127. Now the trick is, how do we represent the friend's distance? Because all we are told is that the friend drives for an hour and a half and reaches Essex. So they cover all the rest of the miles in an hour and a half. Remember that distance equals rate times time. We know that the friend drives 1.5 hours. We're being asked to figure out what the rate is, but that will give me my friend's distance. Okay? So, for friend's distance here, I'm going to replace this with 1.5 times r. 1.5 hours at some unknown speed, and we cover the 127 miles total. All right, solving it. I'm going to subtract 40 to the other side. So I have 1.5 r equals 87. And then when I divide, I get r equals 58. So that tells me that my friend drove an average of 58 miles per hour. And I know it's miles per hour because I was given distance in miles and I was given time in hours. All right, we're going to stop there. So for homework, you guys are going to do both of these parts, 1.3b and 1.4a. So all of this is due tomorrow.